Notes on arc length. So we've already discussed how arcs can be measured in degrees. So this is different. That's the measure of the arc, and this is the arc length. So you do need to be careful in the directions to see which one they're asking for. And of course, if you're not sure, please, please, please ask Ms. Reisman or myself for clarification. Okay? So arc length is part of your circumference. Okay? So we know how to find circumference from the earlier circumference. That's really hard to spell while talking, sorry. We know how to find circumference from the past video. So circumference is 2 pi r, and that's for an entire circle. So it's an entire circle all the way around is 360 degrees. But we only want to find part of it. So some number of degrees, and then we're going to find out what that length is. So this is your formula. We're going to substitute these values in so you can kind of see how they work. So this guy here is our r, and this guy here is our degrees. Okay, so we're going to do 360 over 2 pi. My radius is 2. My degrees are 315, and I am finding out the arc length. Okay, so this guy is a cross multiply. You know how to do this. And we are going to cross multiply these numbers. So we've got 360x equals 315 times 2 pi times 2. You can kind of write that however you want. I like parentheses. So we can multiply all these numbers together. 315 times 2 times 2 should give you 1,260 pi. And then to solve for x, we're going to divide both sides by 360. So we're just going to kind of ignore that pi is there and let him tag along for this part. And 1,260 divided by 360 is 7/2, so 3.5. But since we're giving an exact answer here, we need a fraction instead of a decimal. And our units here are centimeters. And since this is part of a circumference, it is one-dimensional. So there's a 1 here. So that is your exact answer. And our approximate answer, 7 divided by 2 times pi, will give you 10.99557, blah, 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 blah. So if we are still rounding to the hundredth place, we've got to look at the next one over. Since this is a 5, we're going to bump this guy up to be a 10, which bumps this guy up to be a 10, and bumps this guy up to actually an 11. And since you're rounding to hundredths, you still put the 0.00 to show that it's not exactly 11, and it is rounded to that. Okay, so this guy, as goofy as that was, is our approximate, and this guy is our exact. They will not all be that complicated. Try the next 4, and you get them checked with Ms. Reisman or myself.